Hello, and welcome to week 4 of our class. I hope everyone is doing well so far this week. For today's class, I will be covering a very popular library in Python, and that is the requests library. I will share a quick PowerPoint presentation, then I will show you some examples. I will also go over this week's assignments, which will be about the requests library. Actually, we will talk about 4 main methods from the requests library today, and these will be the get method, the post method, the put method, and the delete method. These 4 methods will allow us to work with data on a remote server to get the data, to send data, to update the data, and to delete the data. These tasks are very common, and we use them in all our apps. For example, when you create a new tweet on X, then that uses the post request. When you want to see the latest tweets, you use the get request, and if you need to modify something in your tweet, that will use the put request, and if you want to remove your tweet altogether, that's the delete request. Okay, so the Python request library is a powerful and user-friendly tool for making HTTP requests in Python. It basically abstracts all the complexities of handling various aspects of the HTTP protocol, and so it provides a simple and intuitive interface for sending requests and receiving responses. The library is widely used for interacting with web services, APIs, and fetching data from the web. It makes it easy for developers to focus on the core functionality of their applications rather than dealing with low-level networking details. So, with just a few lines of code, developers can create get, post, put, and delete requests, as well as set headers, handle cookies, and manage sessions effortlessly. And for more advanced behavior, the requests library supports various authentication methods, as well as handling redirects, which are essential features when interacting with web services and APIs. So, if you want to go out to any website, like YouTube and Instagram, and fetch data from that website, the requests library is a great tool to use. Now, the requests library is not part of the standard Python library. This means we need to install it. And to do that, I'll go to a terminal window. From here, I'll type pip install requests. Then I'll hit enter. You can see from this output that I already have it installed, so I can import the request library in my code and use it without problems. Alright, let's go back to our presentation. So once the library is installed, I can now import it in my code as I do with any library. Now the way the request library works is as the name implies. I send a request to a remote device, like a server, and based on my request type and the data sent in that request, the remote device will send back a response object. This response object contains data, like the content of the response, the status code of the response, the headers, and much more. The general usage of this library is to call it by name, then use the dot annotation to call its different methods. We have the get, post, put, patch, and delete methods, all which take arguments, and we will see many examples in a few moments. And here's a very simple code sample of how to use the request library. I begin by importing the library. Then I call the get method, which is one of the available methods in the request library, and I pass it a URL as an argument. What this will do is go out to this web address and fetch data from that server. If all goes well, the server will reply back and send a response object. And in this example here, we assign this response object to a variable x. Once we have a response object, we then can use it to call its methods and properties. And in this next line of code, we call the text property of the response object, which simply returns the text data that was set back in the response. Now, of course, I'm only scratching the surface with this information, so please refer to this website for more documentation. Alright, let's look at our first code example. Here I import the requests library and I alias it as just rec. Then I call the get method of the request library and pass as an argument the Nike.com website URL. So that's the request part of this equation. A request is sent to Nike.com, and hopefully a response will be sent back. When it does, I will store this response object in a variable called res. So now I have a response object and I can call its methods and properties. Here I use the Nike website, but you can use any website you want, and I will be changing these addresses during my examples. So the rest of this code is just a bunch of print statements that show some of these response object properties. The first two are the status code and the reason. If you are familiar with web server status codes, you might know that the value 200 means success, so everything between the request and response went well. In general, 200 level status codes are good. 300 level status codes are informational. 400 level status codes are client error, and 500 level status codes are server error. So we can say that it's okay to get status codes in the 200 and 300 levels, but not so in the 400 and 500 levels. Another property to use is the reason property. If you don't know what status code 200 means, then fetch the reason property and it will tell you in one word what this status code is referring to. For 200, the reason would be just the word OK. Another property of the response object is the headers. These tell us a lot about the server, the response, the time and date, the size, and much more. So it's loaded with good to know information. Then we come to the text property, which is the body of the response object. This is the stuff that we usually are seeking, or the main reason we sent the request. As the name implies, it's just text data. If you are looking for non-text data, then there's another property called content that might be better suited for this task. And for my last line of code, I have it commented out for now. But I'll come back to it in a moment. For now, let's run this code and see what we get back. So I get a status code of 200 and a matching reason of OK. Then this is a good sign that everything worked fine. Next we get the header information. Now this information can vary from server to server, but as you can see, there's a plethora of data here. Then at the bottom, we have the text data, but as you can see, it's thousands of lines long. So instead of going through all these lines, I just want to see the first 500 characters, kind of a way to verify that my code works. So let's go back to my code. I will comment out this line, then uncomment this last line of code. This line is the same as the one above, but with one minor difference. For my text property, I can limit how much data I get back. So if I just want the first 500 characters, then the syntax is as you see it here. In square brackets, I leave the start value blank followed by a colon, then 500. This will only return the first 500 characters in my text property of my response object. So let's run this code again. And now you see that my text is all visible because it's only 500 characters long. All right, let's move on to another code example. This code also uses the get method of the requests library. But now we added a second argument. Sometimes when you are fetching data, you need to specify which specific data you are asking for. For example, we can say, fetch me all tweets that belong to John Doe from last Christmas Day. To do that, we need to pass parameters with our get request. So as one of the arguments in my get method, I pass the params argument and set it equal to the data I want to send along my request. As you can see, I have a variable called PRMS, and I set it equal to a dictionary of two key value pairs. So in addition to the URL, I'm now passing also some data. Then the rest of the code below here you are familiar with the exception of the URL property. But let's run this code now and see what we get back. So I get my usual status code, reason, and headers from my response object. Then in my text property I see the data that I sent, and part of this data is this URL. which was the URL, which was the URL formed when I sent my request. And this part of the text data can be pulled out using the response.url property, so I captured it here as my last part of my code. Again, please follow up by reading the documentation to see all the bells and whistles that come with this amazing library. Okay, now let's look at another method in the requests library. In this code, we use the post method. The post method allows us to create new items on remote devices. Here I import the request library, this time without any aliasing. Then I create a URL variable and assign it a path that is good for testing purposes. Then I create another variable that will hold my data, which is also in a key value pair formation. Next, I call the post method of my request object and pass it these two arguments. The URL is what I defined up here. And to pass my data, I use the data argument and set it equal to whatever data I'm posting. In this case, my data is stored in the variable above. I could also have passed my data as raw data instead of a variable, which you can see in this commented out code. Then the rest of the code you are already familiar with. So let's run this code. What I get back is the usual data and the body of the response. And I also see the form data that was sent. Okay, so we got some good practice on the requests library, and now let's see what this week's assignments are all about. The first assignment is asking us to demonstrate our understanding in using the get and post methods of the requests library. Then the second assignment will be about the put and delete methods. Here, it's asking of us to create a new Python script named http_requests.py. In it, we need to import the requests module and create a function called get_request. This function should send data to a URL using the get method, then print the status code, headers, and the first 500 characters of the response body. Next, we need to create a second function called post_request. This function should take the URL and a dictionary as its arguments. The dictionary is what will hold the data to send to the server. Then we use the post method of the requests library to send the data dictionary to the URL. And when we get back a response, we print out the status code, headers, and first 500 characters of the response body. So let me open up my version of this assignment code. In this one file, I have the get request at the top, and then the second half of this file is the post request. I just separate them by this line of code, which just prints a bunch of star characters. So I begin with importing the requests library. Then I create my function that takes one parameter, which is the URL to use. And in the body of my function, I have a try and except setup, because so many things can go wrong when you connect to a remote device. So you want to make sure you handle your errors gracefully. In my try block, I attempt to get a request and assign the response object to a variable called response. And once I have a response object, I then print the status code, headers, and body. But for my headers, I'm doing something different. I'm calling the items method of the headers class because now I can loop through the key and value pairs to give me more precise control on each key and each value. And for the text property of the body, I only need the first 500 characters, and so I do that here. Then I have the except block, which is a focus on the request's errors. If such errors occur, it will be caught and printed out here. Next, we define the value for the URL variable, and then we call our function and pass it the URL argument. So this wraps up the get function, and let's move on to post function. The setup is very similar to the get function. I import the library, then I create a function called post_request. But this one takes two parameters, the URL and the data dictionary. I follow it with the same try and except blocks. In my try block, I call the post method of the request object and pass it the URL argument. And to pass my data, I call the data argument and assign it the data_dict value which is the parameter in the function's definition, which eventually will be passed as part of the function call down here. Then the rest of this code is the same as the above code, with the exception that I define my data dictionary here. Then I pass it to my function call so that it can be used as part of my post request. So let's run this code and see what happens. But bear in mind, it will return both function calls, the get and the post. Okay, so we get a status code of 200, and that's always a good thing. We also get our headers, but in a nice and well-organized format. This is because we looped through the key value pairs one by one. Then we get the first 500 characters of the response, and you can see it ended prematurely because the full content is more than 500 characters. Then we have the dividing line, so we now move to the post request, which does the same exact thing. We get the success code, the headers, which we see the content length is more than 500 characters, but we only get back the first 500, so the response text is chopped off at the end. So this takes care of our first assignment. We now are able to use the requests library and call the get and post functions. One fetches data and the other sends data to the server. Now let's move on to the second assignment. The setup is almost identical. Actually, it's asking us to name the file the same, so please don't do that and choose another file name for your Python file. So begin by importing the requests module. Then create a function called put_request, and it needs to take two arguments, the URL and a data dictionary. The URL and a data dictionary. The put request will update data on a remote machine. So it will send the data dictionary, and the server will use this data to make the update request. Then for an output, print the status code, headers, and response body. As you can see, most of the requests methods are very similar to each other. Okay, let's move to the second half of the assignment. We need to create a function called delete_request. This function should take a URL string as an argument, send a delete request to the URL, and finally print the status code and headers. So pretty much the same again for the delete request. And here is my code implementation of this assignment. The top half of my code is about the put function. Then I have the dividing line. Then I have the delete code. Let's go up to the top again. I begin by importing the request library. Then I create my put_request function, which needs two parameters, a URL and the data to send. Then the usual code that you are familiar with, a try except block. And in it, I call the put method of the request library and pass it my URL and the data I want to use for my update. Then I print out my status code, headers, and text. Next, I have my except block, which again captures any errors that stems from the request-response transaction. So that ends my function, and next I define my URL value and data dictionary. Then finally, I make my function call and pass it my two arguments. All right, let's move on to the final function, which will use the delete method. First, I import the requests library. Then I define my delete_request function. It uses two parameters, which are the URL and the data needed with this request. Then the usual try and except block. I attempt to call the delete method of my request object and pass it the needed arguments. Then I print out the status code and headers. But I wanted to bring your attention to the last two print statements. This one calls the JSON method of the response object, while this one just calls the usual text attribute of the response object. The text attribute just returns a string of the body of the response object, which is hard to work with because it's just a string, but when we use the JSON method, it converts the data type to a dictionary, which we know how to work with, how to loop through it, and how to extract values easily from it versus a string value. Now, if something goes wrong with the try block code, then the except block kicks in and prints out the error. Then down here, I define what URL and data to use. And finally, I make the function call while passing these two arguments. So let's run this code and see how it behaves. I get the success code, the headers, and then I get the body of the response object. Then I see the dividing line, followed by the delete response. Again, a 200 status code, the headers, and then I get the body of the response object as a JSON format, and then I get it as a string format. They might look the same, but they are different data format. In fact, let me make a quick code change to show the different data types. This just prints out the data type of what gets returned from these two expressions. And so let's run this now. As expected, the JSON method returns a dictionary data type, while the text attribute returns a string data type. Alright, well, this wraps up this video. I hope it was helpful, and if you have any questions, please reach out at any time. Thanks for watching, take care, and bye for now.